Welcome to The Explainer. Today, we're laying out the ultimate robotics career roadmap. We're going to take you all the way from those basic foundational concepts right up to professional innovation. If you've ever, sat there and wondered what it actually takes to break into the robotics field, well, you're in the right place. We're going to map out the exact knowledge, the tools, and the mindset shifts you absolutely need to turn that fascination into a real thriving career. Let's dive right in.
We've all seen those crazy viral clips online, right? A Boston Dynamics robot pulling off a flawless backflip, or the super rapid evolution of the Tesla Optimus. It's just pure awe. But then a question kind of hits you. Wait, how do you actually get to be the person who builds that? How do we cross that massive gap from just staring at a screen to actually engineering in the lab? Well, it all starts by understanding the basic anatomy of a robot.
Section 1. The knowledge architecture.
So, robotics is this incredibly, deeply multidisciplinary field, and it's basically built on 4 essential pillars. Think of mechanical engineering as the physical body and structural integrity of the machine. Then you have computer science, that's the brain, giving it algorithmic intelligence. Electronics, that forms the nervous system, managing all the power distribution and sensory signals. And finally, mathematics provides the underlying kinematic logic. Now, here's the real kicker. True innovation doesn't just come from mastering one of these. It's about integrating all of them together into one cohesive system.
Before we move on, I want you to just pause for a second. Which of those 4 areas, mechanical engineering, computer science, electronics, or mathematics, really sparks your curiosity the most? Figuring out your natural interest is honestly the very best entry point. You absolutely do not need to tackle this entire ecosystem on day 1.
Section 2. Your step-by-step toolkit.
Okay, so transitioning from theory into action requires a really precise 3-step path. Step 1. Learn C++ or Python. Python is fantastic for machine learning, while C++ is kind of the bedrock for those real-time processing speeds your hardware desperately needs. Step 2. Get into simulation. Platforms like Gazebo or RoboDK let you stress test your code in a physics-accurate digital world before you risk breaking any expensive physical hardware. And step 3, join a community. Groups like the IEEE Robotics and Automation Society are amazing places to find the mentorship that is literally crucial for your career growth.
If you want a great example of this, just look at the inspiring story of engineer Zyla Foxlin. She brilliantly blurs the lines between art and engineering. Whether she's building a fully functional wooden rocket or a robotic musical instrument, she uses this exact same toolkit to create deeply functional, real-world projects. Her work totally proves that robotics is a highly creative field where rigorous engineering and personal expression can perfectly collide.
Section 3. Hobbyist to professional. Now, making this jump, it's a massive leap. Every single engineer starts out as a hobbyist, right? You're tinkering on weekends, getting something to work just once on your desk, purely for the joy of it. But the professional operates on a completely different level. They are building for the entire world. And doing that requires a highly scalable mindset. You have to focus heavily on rigid safety standards, reliable repeatability, and of course, collaborating within really large multidisciplinary teams.
Now, as you start adopting this professional mindset, you're probably going to run into some imposter syndrome. Specifically, you'll hit the absolute myth that you need to be some sort of math genius to build robots. Listen, while math is for sure a core pillar, modern robotics is incredibly modular. You literally just learn the advanced kinematics as you need them to solve specific physical problems. You absolutely do not need a PhD in advanced calculus just to write a Python script or run a basic simulation, so don't let that hold you back.
To really ground this in reality, let's look at some actual career titles you might aim for. First up is the integrator. Think of the integrator as the conductor of an orchestra. They're the professionals making sure that the mechanical body, the electronic nervous system, and the computer brain all actually communicate with each other seamlessly. They take all these completely disparate subsystems and bring them together into one beautiful, functioning machine.
And then, of course, we have the programmer. These are the folks who write the complex logic dictating the robot's behavior and movement, whether they're utilizing C++ to optimize a split-second physical reaction or using Python to process incoming visual data from LiDAR sensors. They are essentially translating human intent into robotic action. And honestly, these are just 2 of the many highly tangible roles waiting for you out there in the industry.
Section 4. Your local robotics mission.
All right, so here is a highly structured 6-month roadmap to kickstart your success. For month 1, just commit to the basics of C++ or Python so you can really grasp the syntax.
Fast forward to month 3, you're going to apply that code to digital models in Gazebo or RoboDK, literally watching your logic move a virtual object on screen. By month 6, it's time to build your own physical project. Look, it doesn't have to be perfect, but doing this takes that incredibly overwhelming idea of building a robot and breaks it down into a totally achievable, guided practice.
I want to leave you with one final, kind of provocative question today. Look out your window. What local problem in your very own neighborhood could be solved with a robot that you build? Because at the end of the day, professional innovation is all about building something genuinely helpful. Maybe it's automated recycling sorting, or perhaps some agricultural assistance for a local community garden. Start small. Lean on that multidisciplinary architecture we talked about, stick to your roadmap, and you know what? Maybe one day you'll be the one building the exact solution the world needs. Thanks for joining me on this explainer.